Assalamualaikum and good afternoon everyone. You can scan the attendance, and if you have problem doing so, you can leave your
Good
metric
morning.
number
Afternoon.
in the chat box. I will key in manually later if you cannot scan. Just leave your metric number. Seems like no one is able to scan the QR code. I don't know what is happening with the QR. Maybe we have some problem there, but never mind. You just leave your metric number in the chat box. I will try to manually key in all the attendance later. I'm sharing the screen. Give me a moment. I'm looking for my slide. All right. Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to everyone. Thank you for coming to our class today. This is our first class for the subject STK 1213 Analytical Chemistry 1. So before we start with learning unit 1 of this course, I would just like to brief on this course as a whole. how we are going to conduct this course and what are the learning units, how you are going to be assessed, and so on. All right, first of all, let me introduce myself. My name is Dr. Rafiq Awahi. I'm a lecturer in Resource Chemistry program. I know today in this class, we have a mixture of students from Resource Chemistry program and also from other programs. So I have been teaching in UNIMAS since 2002, and analytical chemistry is one of the subjects that I have been teaching for more than 15 years. This is my number. This is my handphone number. You can WhatsApp me, and you can also add me to the WhatsApp group for this class, so that we can communicate better and more frequent if you need to. And then this is my email. You can reach me through these three methods, whether you call my office number or my phone number or my email. Okay, you can email me. Basically, I was trained in engineering background, although I'm in resource chemistry program in UNIMAS. But I was trained in mineral resources engineering and environmental engineering. But analytical chemistry is not something new to me, because my research expertise is on waste processing and utilization technology. So we deal a lot with analytical methods. We deal a lot with samples, characterization, and so on, qualitative and quantitative analysis. And analytical chemistry is one of the things that, one of the subject that I love most teaching. So for this course, there are three learning outcomes that we are trying to achieve throughout this semester. So upon completion of this course, students should be able to, first, to infer analytical chemistry principles to solve problems associated with chemical analysis. Meaning to say that you can infer analytical chemistry principles and use them to solve problems, chemical analysis problems. And then number two, at the end of this course, you should be able to relate the analytical chemistry principles to its application. Sorry, I think it's raining heavily here, so it's quite noisy. I'm sorry about that. And CLO3, upon completion of this course, you should be able to select appropriate techniques in solving chemistry-related problems. Meaning to say that when you have analytical chemistry problems, you know which technique, which calculation, which principles you should be able to apply to solve them. All right. So in this course, the teaching, learning, and assessment approach is as follows. For teaching learning, we will conduct what we have usually conducted for this course face-to-face. Normally, we have tutorial, discussion, lecture, and also group work. So what we are going to implement in our online learning situation is also the same thing, but we will try to conduct the lecture for group 3 and group 4. The lecture would be only 1 hour per week. And another remaining 2 hours, we will do some activities on eLeap, whereby you can complete them anytime before the next lecture. For example, we have lecture today on the 19th of October. So before next Monday, you have to complete all the activities done for today's session on eLeap, and you have to attend 1 hour of lecture. All right. Why 1 hour of lecture? That's because I think most of the things that we learn in analytical chemistry 1 is about solving problems. So you will work on the problems by applying all the concepts that I shared with you in 1 hour lecture. So you can have a better understanding on what you are learning. You can learn at your own pace. You don't have to, you don't have to uh, you don't have to be stressful to finish everything in 3 hours, but you have your own time to do it as long as you finish everything within 1 week. All right. So all the group work and discussion will be done on eLib as well. And the tutorial, we will give you some videos showing calculations on how to do certain types of calculation problems, and then you will apply them to solve the calculation and the study questions given. All right. About the assessment, there will be 2 assignments, 1 quiz, midterm examination, and also final examination. And this is how you are going to be assessed. You have 2 assignments, assignment 1 and 2. Assignment 1 is 15%, assignment 2 10%, quiz 5%, mid-semester exam is 30%, and final exam is 40%. If you look at the proportion and weightage of the assessment, most of them are from the mid-sem exam and the final exam. It's going to take 70% of the assessment for you to conduct it based on exam. Okay, why based on exam? Because all the concepts and principles in this course is fundamental for you to be familiar with, to be able to apply the principles to solve problems. Because later on in other courses, in other chemistry courses, you will apply the basic concept from this course. So that's why most of the things we have to test it through examination. Okay, however, you still have the chance to score 30% from assignment and quizzes. All right, don't worry. And we are going to give a lot of tutorials and examples as well for you to be able to apply uh, the techniques for solving problems in analytical chemistry. So these are 6 learning units in this course. First, we are going to learn some overview on analytical chemistry, which we are going to do it today. And the next one for learning unit 2, we are going to learn about stoichiometric calculations, LU3 gravimetric analysis, LU4 acid-base equilibria, LU5 acid-base titrations, LU6 analytical separations. I believe all those topics you have learned it during your previous learning experience, for example, during your STPM, during your matriculation, during your foundation studies. So this is just going to be a revision, if not a little bit advancement in the way we use these principles, all right, again, to solve chemistry problems. Okay. All right. Any questions regarding the general um, information about this course?
No.
No. All right. Then before I start with learning unit 1, I would just like to share with you um, the schedule of this course, the teaching plan. Let me stop sharing the slides and start sharing the schedule. Just give me a moment, okay? All right. Sorry, give a moment. Okay. Okay, if you look at this proposed teaching plan for STK 1213, we will have lecture until week 6, and you will have your mid-semester exam by week 7. All right, so on week 7, the mid-semester exam will be on the 24th of November, which is on Tuesday. You are going to utilize the schedule for STK 1211. We are not going to have any learning session for practical analytical chemistry on 24th of November, but instead you are going to have your mid-semester exam, right? And assignment 1 will be given on the 5th week. Before I forgot, for your mid-semester exam, you will be tested on learning unit 1, 2, and 3. And it's going to be 2-hour exam. Okay. I will, specify the specific location or the specific platform for the exam, because last time when we did the online exam, we do it on ELIP exam. Okay, we have one platform. It's not ELIP for teaching learning, but it's ELIP for exam. So I will let you know later whether we are going to use that platform or any other platform. Yeah? All right. And assignment 2 will be on week 11. Quiz will be on week 12. And your examination, final exam, would be in starting 25th January to 14 February. That is 3 weeks. There is going to be 3 weeks of exam week. We still don't know yet the schedule, the specific schedule for this course. All right. Now this is how you are going to be assessed. As I mentioned just now, for mid-semester exam, for example, you will be tested on CLO1 15%. So meaning to say that 15% of the questions will come from CLO1, which is to infer analytical chemistry principles to solve chemistry problems. And then CLO2 5%, CLO3 10%. So it's going to be 30%. Okay. Okay. Any question on midterm? Jelas ya? So it's clear. Let me share once again the slides just now. Alright, let's start with LU1, which is Analytical Chemistry Overview. So at the end of this learning unit, you should be able to define what is meant by analytical chemistry, and you should be able to explain the application of analytical chemistry. Okay, and then you should also be able to distinguish and explain what is the meaning of quantitative analysis and qualitative analysis, explain the steps involved in chemical analysis, understand common analytical problems, and explain quality assurance in analytical chemistry. And use different units of concentration. However, for for outcome F, I will straight away cover this one in learning unit 2 because there are some redundant information on what we are going to learn in LU2. All right, so I'm going to cover only A to E today. So what is analytical chemistry? Analytical chemistry is a metrological science that develops, optimizes, and applies measuring processes, which is intended to derive quality chemical information to solve the measuring problems. So when we talk about analytical chemistry, we talk about developing methods of optimizing methods and apply the measuring methods for us to derive quality chemical information. We want to know chemical information of our sample, okay, by using measurement techniques, appropriate measurement techniques to solve the measuring problems. All right. Basically, analytical chemistry is the science of measurement, and it has a dual character. One, the basic character is it develop methods for measurement of chemical information, and practical, it applies methods, measurement methods to solve chemistry problems by using analytical techniques. Okay, so the purpose of analytical chemistry is to deliver information about the material or the system that we studied. So we measure all about it. We measure the chemical information about the sample, the material, okay? And the measurement process, the measuring process is called analytical processes. So we use analytical processes as a tools or vehicles for obtaining chemical information. So there are three key points. There are two key points here. One, analytical chemistry is a science of measurement to deliver chemical information. Okay, science of measurement. And number two, deliver chemical information. That is the purpose of analytical chemistry. Right, what is the applications of analytical chemistry? Actually, analytical chemistry is all over the place. It is in almost every branch of our lives. For example, when the forensic people are trying to try to solve crimes, by using forensic chemistry, they are actually applying analytical chemistry techniques to do the analysis of the samples and to understand um, what are the leads that can help them to solve the crime based on the chemical information obtained. Okay. And another example of how analytical chemistry is familiar with our life is um, its application to point out harmful chemicals used in consumer products. For example, if we talk about supplements, if we talk about makeups and skincare, we always think about we want to use a safe product which has no harmful chemicals inside. So how do we ensure this? We ensure this by applying the techniques for analytical chemistry in order to uh, in order to ensure that there are no harmful chemicals in our products, right? And another clear example of how analytical chemistry is applied is in medical research. For example, right now, the hot topic is about finding the vaccine for COVID-19. So analytical chemistry is very important to as one of the tools and as one um, of the methods that people in medical field do in order to find a solution to a disease. Okay. Again, analytical chemistry is not only for chemists. Analytical chemistry is for people from many branches of sciences or non-sciences. For example, in chemistry, it's obvious. We use analytical chemistry a lot, even though we are learning or doing things in organic chemistry or physical chemistry, we still need analytical chemistry. And then in physics, in engineering, in physics, for example, when they take samples from another planets or from moon, you still have to use analytical chemistry to identify the composition of the material, your samples from those places. And in engineering, in civil engineering, chemical engineering, electrical and mechanical engineering, they are also components of materials which need to be analyzed, need to be identified, the characterization, so that they can make the best material or the best, structure for the building, for the chemical product, and also for the electronic products. Okay. Same goes with medicine, as has been discussed just now, in material science, even in social science. Even though we look at social science as something which is not related to sciences, but it somehow use or utilize analytical chemistry. For example, if you take samples from archaeological sites, let's say a mummy or a soil samples or anything which is related to archaeology, you bring the samples to the lab and analyze them in order to find out certain chemicals or certain composition which can tell you the story of the archaeological artifact. Okay, for example, the age, from which century it comes from. So this is how analytical chemistry is utilized even in social science. Okay, and then we have agriculture sector, environmental sciences, geology, and biology. They all need analytical chemistry. So when we talk about analytical chemistry, there are three important terms that you need to understand. Okay. First, the term analysis. Analysis means a process that you do to provide chemical or physical information about a sample. So when you want to do characterization analysis, for example, it means that you want to provide characteristic information about the sample. Okay, so analysis is a process done to provide chemical or physical information about a sample. The second important term is the term analyte. You are going to hear or listen to this term many times in analytical chemistry course because it's all about analyte. Okay, when you do analytical chemistry, analyte is the component of a sample that are to be determined, or we call it a component of interest. Let's say just now, when you go to an archaeological site, you take a soil sample. So your sample is the soil. But what do you want to determine from the soil sample? Let's say you want to determine the level or the concentration of calcium oxide in the soil sample. So your analyte is calcium oxide. Your sample is soil sample from archaeological site. Okay, so I hope you understand the term analyte here. Analyte is the component of interest which exists in your sample. All right. Now the term determination. Determination is an analysis of a sample to find the identity, the concentration or the properties of the analyte. Let's say when we want to determine the heavy metal content in water samples. Determination means um, we want to do an analysis of the sample to find the identity, the concentration or the properties of water sample. Okay, that's one example. So make sure you understand and you can differentiate the three terms: analysis, analyte, and determination. So we can understand how questions and how chemistry problems are made into sentences, and you can understand how to solve it. Okay. There are two main types of chemical analysis. The first one is qualitative analysis and the second one is quantitative analysis. Qualitative analysis is a process to identify the chemicals present in the sample. In this case, we want to know what is present in our sample. Okay, for example, what are found in your drinking water? Let's say you find iron and you find zinc in your drinking water. That's called qualitative analysis. What about quantitative analysis? Quantitative analysis is the process of separating, identifying, and quantifying the relative amounts of the components of an analyte. Okay, remember just now, analyte is the component of interest in our sample. For example, we have water sample. We want to know how much is our analyte, which is iron and zinc, in the sample. So we do quantitative analysis. Meaning to say that, in short, quantitative analysis is about how much each of your analyte exists in your sample. In this case, we are going to quantify it in terms of concentration of iron, which is 0.05 milligram per liter, and concentration of zinc, which is 0.01 milligram per liter. Okay, so qualitative analysis is about identifying what is present in your sample, and quantitative analysis is about how much of the analyte exists in your sample. Okay. All right. We are going to do some activity here. Can you give me one example of qualitative analysis and one example of quantitative analysis? Okay, you try to Google the answer, example of qualitative analysis and quantitative analysis, and type your answer in the chat box. I'm going to look at the chat box and see if we have any answer here. And while waiting for you, I'm going to give another example on how qualitative analysis and quantitative analysis is different. Let's say you have a diabetic patient. Okay, diabetic patient, or we call it kencing manis. Okay, so when you have diabetic patients, there are two types of tests that can be done to them. Okay, the first one is they do urine test. When they do urine test, the aim of the urine test is to identify whether the urine sample uh, has glucose content. Okay, so what do you think is this? Is it a qualitative analysis or quantitative analysis? You can use the chat box to answer, or you can use the microphone. Urine test for diabetic patient is identifying glucose, whether it is is detectable in the urine sample or not. Is it qualitative analysis or quantitative analysis?
Qualitative.
Okay, some of you
Quali-
answer qualitative and some says quantitative. All right. Okay. It's qualitative. Why do you say qualitative? Qualitative because it identifies what is the analyte presence in the sample. Okay, in this case, the analyte is glucose and the sample is urine sample. What about if you take blood sugar sample? Mean to say that you want to know the level of glucose in the patient's blood. You take the blood sample and you put it on a kit, and it will show you the reading of how high or how low the sugar content or the glucose content in the blood sample. So that one is called quantitative analysis because you know the number.
Quantitative.
Yes, you know the number. You know what is the value, whether it is 5.6 millimole or millimole per liter, or whether it is 12, whether it is 13, and so on. So you have the number, you have the value, so we call it quantitative analysis. That's an easy example. All right, I've given my example. Can you give your example? I think somebody has already answered just now. I'm just waiting for other people to answer as well. What are the examples of quali and quanti? I think somebody answered just now. I'm trying to look for the answer. Okay, quantitative analysis, Nur Shuhada said. For example, titration, gravimetric analysis. Okay, titration is quantitative analysis because from titration you can derive value. For example, if you are looking for concentration of acid in an acid and base titration, you can actually quantify the concentration of the acid after you finish the titration process. So great. Quantitative titration is one of the example of quantitative analysis. Gravimetric analysis. Yes, gravimetric analysis is also a type of quantitative analysis. Determination of blood cholesterol. Yes. Qualitative analysis. I'm not sure about blood cholesterol, but when I did the yearly checkup, yearly health checkup, they have number for blood cholesterol, meaning to say that that would be quantitative analysis. Okay. Joel says quantitative color, gender, qualitative height and mass. Can we have, Joel? Can we have examples in the form of analytical chemistry context here? Maybe you would like to answer. Maybe you would like to try again after this, Joel. Siti Maisara said qualitative analysis test for anions. Can you elaborate more, Siti? What do you mean by test for anions? It's quite general there. Quantitative analysis, blood cholesterol level, qualitative flame test. I get this answer as well this morning. The flame test for identification of elements, right? Yes. Qualitative analysis, iodine test, quali, gas color, quantity, number of mole of salt. All right, more or less you know that. Qualitative analysis is about what analyte is present in your sample, and quantitative analysis is about how much the concentration or the value of each analyte in your sample. Anyone here there just now? I hear somebody is going to talk. No, okay, all right. We just continue to our discussion. All right, these are the examples of quantitative analysis. I'm not going to elaborate more on each of the analysis because it's only important in this learning unit that you understand that quantitative analysis is about quantifying the value or how much is your analyte in your sample. Okay. So gravimetric analysis are analysis method based on a measured weight. For example, if you determine the suspended solid content in water sample, so that is called gravimetric analysis. Okay, you measure the weight of the suspended solid and then there you go. You get a value on how much suspended solid is contained in your water sample. Next is volumetric analysis, for example, titration. Electroanalytical methods, for example, electrolysis, which can give you the concentration of your analyte. Chromatography analysis, where you do separation of your material from different phases. And then spectroscopy, interaction of analyte with electromagnetic radiation. No problem. It's okay if you don't know this yet, because what I'm trying to convey here is that we have these methods for quantitative analysis. They are only examples. There are a lot more methods that we have. For example, we have voltammetry, we have kinetic methods, and so on. So this table is showing you that when we have different methods of analytical chemistry based on quantitative analysis, we also have different precision, selectivity, speed, costing, and reliability of the techniques. Okay, so gravimetry techniques, titrimetry techniques, and other techniques, they have different level of uh, quantification range and so on. Okay, detection level, the precision, the speed, they are different. Okay, so you will have to decide which one to use based on several factors which I will elaborate after this. All right. Now, um, when we talk about quantitative analysis, there are 9 steps in typical quantitative analysis. Okay, in all quantitative analysis, we need to follow these 9 steps in order for us to come out with the results of our quantitative analysis. The first one, you have to define a problem and then you have to do method selection based on the problem. And then you do sampling based on your method selection. And then preparation of your laboratory sample based on your method selection and based on your defined problem. And then you do replication of samples. You prepare relevant solutions if you need to dissolve the samples. You do elimination of interferences, and then you measure property of your analyte, and you do calibration. And then the final one, after you have do measurement of your analyte, you do data analysis, whereby you calculate results and you estimate the reliability of your results. Okay, you don't have to salin this one. You don't have to copy this one because it's in your lecture notes. But if you want to, you can concentrate on understanding what each of the steps means. Okay. So the first step is defining your analytical problem. What do you want to determine? Remember just now we talk about determination. Determination means you is a process you do. Um, it's a process you do to identify the identity of your material or anything. Okay. So when you want to define a problem, there are certain factors that you have to consider. For example, what is the problem that you are trying to address here? This morning, I gave an example about the archaeological samples taken from archaeological sites. Let's say you take the soil sample. You must be able to determine what you want to be found from that samples. Do you want to find the heavy metal content of the soil? Or do you want to find calcium oxide from the soil? Why calcium oxide? It may be related to some of the components of all edge tools. Okay, or do you want to find only the edge of the uh, material found in the soil? So you need to be specific on the problem that you want to determine. Okay, and then what will the information be used for? Who will use it? And then when will it be needed? Because if you need the data to be available fast, maybe you have to choose a faster determination process, analytical technique, faster analytical technique. As has been mentioned in the previous table here, we have different speed, different cost, different detection range, different precision. So you might want to choose a different method based on your need. If you need a fast method, then you might want to choose uh, potentiometry. All right. How accurate and precise does it have to be? Okay, what is the budget? The analyst should consult the client to plan a useful and efficient analysis, including how to obtain a useful sample. Let's say just now you want to determine cholesterol level in blood sample. What kind of precision do you want? Do you want total cholesterol, or do you want only the LDL cholesterol, or you want only the HDL cholesterol? So which one? If you want a more specific one, you need different method. If you need only the general one, you need different method. So this is where you do identification of a problem, of your analytical problem. Okay, so the first thing in analytical process for quantitative analysis is to define a problem. After you have defined your problem, you do method selection. Just now I mentioned about different speed, different analysis range, different detection limits, different reliability. So this is what you use for method selection. Okay, it's based on your sample type, size of sample. If we have more samples, you may be using different methods than if you have a small size of sample. And then sample preparation needed, concentration and a range of detection, which is, we call it also sensitivity, and then accuracy, precision, what are the tools or instrument that is available, and then expertise, who wants to carry out the analysis, the cost. Okay, this is how you select the methods. You look at the factors which to help you to decide which method to use. Okay. For example, if you want to determine oil and grease content in a food sample, there are two methods. Whether you use instruments, okay, oil and grease analyzer, you just put in your sample and they will give you readings, or you have the wet method, traditional wet lab method, wet laboratory method. So you choose it based on what is available on your side. For example, you don't have that instrument, so the only choice is for you to do the traditional standard method. Okay, and that would require a different kind of preparation compared to the instrumentation analysis. Okay, so this is how you select your method. Then after you select your method, you do sampling of your material for analysis. Why do you think we need to do sampling only after we select our method? Why do you think so? Anyone have an idea? You can answer in the chat box. I'm looking at the chat box. Any answer? Why do you think we do sampling after we determine the method? Why not before we determine the method? Let's say we have to do a forensic investigation. We already have the dead body. Why don't we just take sample as much as we want, then we decide which method to use, instead of deciding first which method to use, then only do the sample? Why would we do that? Why would we do that? Can anyone answer? Just try to answer anything. I'm waiting. Anyone? Shuhada, Emmanuel, Shadali, to avoid wasting of material,
Um,
to save cost, because every sample has their own method, to obtain more accurate result, not to waste the sample. All are good answers. All are good answers actually. Okay. Those are the reasons why we don't want to do the sampling before we determine the method that we want to use, because different method will require different sampling. Okay. And not only different sampling point, but maybe also a different sampling size. Okay. So in sampling your material or your sample, you have to obtain a small mass of a material whose composition accurately represents the bulk sample. For example, when we are doing analysis of cancerous sample. We do the biopsy, for example. Okay, we take sample which is related to the area which is suspected cancerous, for example. So that is called taking representative sample. Another example of taking representative sample is for people who are doing water analysis in a river sample. Let's say you are doing water quality determination of Baram River. Baram River, Baram River is very long river. But you take only one sample from one sampling location. And then when you report it, you report it as water quality at Baram River. Would that be a representative one? Of course not. Okay, of course not. Because you want to report a representative conclusion for the whole area that you are reporting. For example, if you want to report for Baram River, then you take samples not only from one sampling location, not only from one sampling points, but you have to take from many points. And from each points, you have to take replicates of sample, which will be mentioned after this. Yeah. And then when you already take your samples, you bring the samples back to the laboratory for analysis. You have to prepare the sample. Let's say just now you take sediment samples from Baram River. You take sediment samples or soil sample from Baram River and you want to determine what is the heavy metal content in the sediment of Baram River. So when you take the sample to the lab, you have to do some preparation because you cannot straight away use the sediment sample for analysis in instrument. In this case, when you want to determine heavy metal content in a sediment, you need to use, for example, atomic adsorption spectroscopy method. So when you use this sample, you cannot put the sediment as it is into the sample and expect the results to come out. You need to do preparation first. So the sediment, you subject it into aqua regia solution. Okay, it's the mixture of HCl and HNO3. You digest the sample, you subject it into heat, and then when you obtain when the digestion is over, you filter it and then you prepare the solution, and then only you can subject it to AAS or atomic absorption spectroscopy analysis. So that's what we call preparation of your sample. Okay, you have done the sampling, you have to prepare it first before you can do analysis. So when you do analysis, you have to replicate your samples. um, Most of the time there will be uh, two situation where you need to replicate your samples. First, when you are doing the sampling. When you do the sampling, you do replications of samples. And when you do the analysis, this is second one. When you do the analysis, you need to also replicate the sample because you might not know there are some interferences in your analysis. Yeah. So what is replicate of samples? It is a portion of material of approximately the same size that are carried through an analytical procedure at the same time and in the same way. Everything is exactly the same. The analytical procedure is the same. The sample size is the same. Okay. So the purpose of replication is to improve the quality of our analysis and to minimize error. Okay. Later on, when you do titration, acid-base titration, it's always being done in replicates, always in at least 3 replicates. Yeah. So that you know which replicates are okay to use, which are not okay, which might have some problems with it, and so on. Yeah? And then step number 6, to prepare solutions of the sample. As has been mentioned just now, when you have samples, you have to prepare it, and when it involves solvents, you have to prepare the solution for your sample. As has been mentioned in the previous example on analyzing the heavy metal content of the sediment, okay, of Sungai Baram just now. You choose one solvent, you dissolve, and you digest the sediment. So what you do is you dissolve the entire sample completely without decomposing the analyte. Okay, you choose solvent which can help you to dissolve the entire sample, but not decomposing the analyte that you want to determine. Okay. Number 7, eliminating interferences. Interferences are substances that prevent direct measurement of the analyte and must be removed. For example, if they are contamination of samples, you have to remove it, whether by using filtration or chemical separation. And then number 8, step 8 is to measure property of analyte and calibration. Actually, for number 8, we do calibration of the instrument first, and only then we measure the property of the analyte. Why? Because as simple as weighing your sample, let's say you want to weigh 0.04 gram of sodium hydroxide. First, you have to make sure that your analytical balance is already calibrated properly. Then only you can be sure that when you weigh your sample is accurately weighed. Okay, that is as simple as weighing your sample. But for all instruments, normally we have to do the calibration of the instruments first to make sure that the further reading that being done by the instrument is okay, yeah, is accurate. So we do calibration first, and then we measure the property of the analyte. And this is the example of calibration. All instruments, they need calibration. This is only one example of calibration curve. It is the relationship between the measured response and the concentration of the analyte. Let's say C here is the concentration, Kx is the technique response. And all calibration, we want to have all the points as as close as possible, okay, to the straight line. And then when we do that, we can proceed to determination of our analyte. The last one is the data analysis. When you already run your sample, when you already have raw data from your analysis, you extract all the raw data, you process the raw data. For example, when you do analysis using instrument, you don't straight away use the data that you get from the instrument. You need to process them first. Okay, so this is called data analysis. In data analysis steps, you require the raw data to be processed, and then you relate the data with the stoichiometry of your reactions and the instrumental factors to calculate the analyte concentration. I'll give you a very simple example of how you do data analysis. Let's say you are doing acid and base titration between an acid and a base. You want to determine the concentration of acid here. So the titration data is your raw data. What is the volume used to titrate the acid until it comes to the endpoint? Okay, so that is called raw data. You cannot use straight away the raw data. You have to calculate first from the raw data how many moles, how many how many moles, how many replicates you have. You have to calculate the average, the standard deviation, right? You have to find out the molarity and so on. Then only you come out with the results. Okay, from here you evaluate the results and you estimate their reliability. For example, you use statistics. When you have replicates, you calculate their mean or the average, and you also calculate their standard deviation. Sometimes when you compare data, you are going to compare whether there are any significance in the data or not. Okay, so this is the part where you call it data analysis. Bear in mind then that what I shared today is about the steps in quantitative analysis. It's not for you to, digest the whole examples, because I understand that it's very hard to imagine all the instruments that I mentioned just now when I said atomic absorption spectroscopy or any other instruments. But the most important part is for you to understand that in all quantitative analysis, there should be the 9 steps, okay, in order for us to get a reliable data and accurate results. Okay, I think I stop here today for LU1. The rest of LU1 I will continue next week, and try to do some of the discussion in ELIP by this week or before our next lecture. And if you have any questions before I end this session, every week we are going to have only 1 hour of lecture, and another 2 hour we will spend it um, using our own time. So if you have any questions, you can ask here before I end the lecture. And if you haven't leave your metric number yet, you can put it in the chat box. Okay, you don't have to rush jotting down all the notes and so on, because all the notes will be given. The recording of the lecture will also be given. So I think during lecture you just concentrate on understanding and jotting down only the most important points. Okay. So if you don't have any questions for the time being, I would just like to end this session. Please add me to your group WhatsApp so we can communicate. And then thank you for having me, for attending the lecture today. If you have any problem, you can always ask me. Okay? Thank you very much, everyone.
All right.
Thank you.
Okay.
Thank you.
Thank you, Miss.